Okay, so this is just a quick video to show anyone who's interested how this Robo sub CV test bench I set up works. So you can clone this repository, and here's what's in it. There's utility scripts to download the test videos since I don't want them in the GitHub, and a couple of quick demos. Let me just run through the demos to show you how it all works real quick. So the first thing you're probably going to want to do is run the utility scripts. Everything's Python 2.7. First thing you'll probably want to do is download the test videos. So you're going to run that script. It'll download the zip and unzip them into test videos. And you can run the download demo data. This downloads the neural network weights. See, now we have demo data and test videos. So the first demo I can show you here is going to be my buoy detection algorithm that I wrote. There's a description in the Readme. So when you run the script, you can see the parameters. It takes in the test video. There's only one right now. It's just this one video of a buoy. It takes in the test script. So there's the path to my test script. And it takes in a couple of algorithm-specific parameters for the neural net model and weights. So this is just the open CV2 image window. You can see the mouse over shows you things like the colors, so you can do color thresholding from this. On the left, we have the video, which will be overlaid with any buoy detections. And on the right, we have the canny edge detect. So we're doing edge detection on this image to simplify it. And then we're doing MSIR blob detections. So it's picking up any blobs, it's running them through the neural net to decide if they look like a buoy. You can see the buoys there showing up on the edge. You can see we just picked it up. And we're drawing a circle around it. It's blue, which indicates we're not sure what color it is. So we're going to keep getting closer, and turned red. That means we've detected it as a red buoy. And, you know, we detected it from fair distance when we're close up. This doesn't work so well, but lets you pick up buoys from a ways away and turn towards them and head towards them. The second one is a really simple, the Hughes circle demo. You can see there's not much to it. It does an edge detection, Gaussian blurs it. I don't actually think this is necessary, and runs Hughes circles with some tuning parameters. So Hughes circles is a CV algorithm that just detects circles, and since buoys are roughly circular, it detects them. So the last one I showed you has very few false positives. This one, on the other hand, if we were to show it anything but buoys, it would probably still detect circles. Oh, wrong script. Hold on. So here is the Hughes circles detection. So in this case, I don't have the secondary image to the side. We're just showing the main stream. You can see the buoys in the distance. So this one doesn't detect until it's much closer, but it does do a better job at close distances. So you can see we got a nice lock on that. And in case you didn't know, I'm hitting spacebar to advance the image. You can see we've detected the buoy, and we're not picking up, say, you can see the two yellow hedges in the distance. We're not picking those up, which is good because they're not circles. So now, if you want to write any code, I have this test script, which is in source demos empty CV test. I added some code in here just so it does something. But you can see where you put your CV code. Everything else is boilerplate. Then you can go ahead and run. Where is it? I think it must. Okay, so yeah, you can see I've supplied a test script, source demos empty CV test, and the buoy test video, and I run this. So this script, just so you can see what I've added to it. I've added two color thresholds, and basically this is trying to detect the yellow, or sorry, the red in this image. Now, anything that's not red, it's going to darken by dividing it by 4. So you can see the image is much darker, and you'll see the parts that it color thresholds as red will show up much brighter. So you can see the buoy in the distance. Soon it's going to start picking up some of the red. There we go. So you can see it's starting to detect that red color thresholding, and that's showing through. So we can detect the red buoy simply by color thresholding when we're nearby. So I'm going to hopefully be putting up So, for example, you see these distant lines. You could hopefully detect those with yellow color thresholding. So I'm going to put up a lot more videos. I'm going to segment our ROS bag files, which contain all our video from competition, and I'm going to put them into that zip file so you can download the test videos, and you can try various CV algorithms using this boilerplate code. Just to give you an idea, here is the main script that loads, your subscripts. It basically just reads a video, sends it to your test function, and shows it to you. Or it also has an option where you can put an output video. So if your code's working really well and you want to show it on the Slack, you can run it with this output video option and give it a path to where you want to write it. You get an MP4 of what your debug image output was. So the image you would have seen coming out of your debug, and you can post that on Slack. If you look at the actual demo codes, just for example, I'll show you my code, which is here. It's a lot longer, so it does a lot of stuff to make sure we don't get any false positives. But you can, here's the main processing loop, and there's all kinds of fun stuff and comments. So you can read through this code, try to get an idea. If you look at the Readme, there's an explanation of how my code works. Anyway, so hopefully you'll find this useful. You can get up and running. I'm using Ubuntu, obviously. It's the best thing to use is any kind of Linux. Just got to install Python, OpenCV, NumPy, and for my test code, you also need Keras and a neural net backend like TensorFlow or Theano. And if you have any questions or any problems, just come post on the Computer Vision Robo sub Slack, and I'll try and keep up to date on everything happening there. If you have any bugs, any exceptions, just post them there. I'll try and help you out. Anyway, so that is the test bench. Hopefully you find it useful.